We're looking at section 2. Again, we are simplifying, but now instead of a single term on the numerator, single term in the denominator, we have 2 or 3 terms. We have binomials and trinomials that we're working with. Like before, we're also going to deal with excluded values along with the actual simplified fraction. Before we get too far into this, this is a good time to pull out our flowcharts. And so this flowchart, you should have a paper version of this. What I find is that all of these steps might look very complicated now, but this is the whole unit on one page. And so when you think of it as, wow, everything we're going to learn for a few weeks is condensed into one piece of paper, this isn't too bad. I just got to figure out how to use this roadmap. So what we're going to be doing is simplifying, which means that I don't need to divide or multiply or add or subtract, anything like that. I need to start at my start, do those things, and go straight to the bottom where I will then be simplifying. So I will be doing these 3 things here, these 2 things here, and that is it. And so this is not nearly as involved as it otherwise might look like. We are going to completely ignore all of this. We don't need anything about equations. We don't need anything about adding or subtracting. So don't look at all that stuff all around the page. Just focus right down the middle. We're going to start the problem, and then we are going to simplify a fraction. We only have one fraction we're dealing with. Step 1 says parentheses around the entire numerator and the entire denominator, and then decide what operation. The operation is just simplifying. So parentheses around the whole things, and then we're going to drop down here. So let's start with this example first. Parentheses around the entire numerator and entire denominator. Boom, boom. The reason that we're wrapping things up in parentheses right away is that we want to treat these as entire terms. If we didn't do this, we might see a 5 and a 25 and say, oh, divide that by 5, divide that by 5, we're good to go. You can't actually do that. That would not be equivalent. So by wrapping it up, we see that, oh, we have a b minus 5 chunk, and that does not match with this, so we have 2 things that do not reduce with each other right now. We need to change something about it if we want to try to reduce it. So we go back to our chart. What is our next step that we're going to work with? We need to, it says down here, factor all groups fully. So we need to somehow factor everything. What does that mean? Well, up on top here we have b and negative 5 as separate terms. There's nothing in common about those two. Nothing that we can take out. So that one's actually fully factored. It's just stuck b minus 5. On the bottom, b squared, negative 10b, and 25. These two have a b in common. These two have a 5 in common, but all 3 of them have nothing in common either. However, if you remember, when we have 3 terms, there's a different way of looking at these where we say what multiplies to the number on the end and adds to the number in the middle. And when we do that, we can come up with 2 binomials. So we're going to say, what is the way that we can multiply to 25 and add to negative 10? And so I always like to start a little thing on the side here that's got 25. I always start with the multiplying and say, how can I multiply to 25? 1 times 25 will work, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 times 5. And once I've reached the same number on this side as this side, I stop. I know that I can't go any farther. So 1 and 25 add up to 26, so I want it to add to 10. 5 and 5 actually add to 10, so that's perfect. I feel like I found my numbers here. But this one adds to negative 10. So in order to multiply to 25, if I made both of these negative, still multiplies to positive 25. 2 negatives multiplied makes a positive, but when I add them, I get negative 10. So my 2 numbers are going to be negative 5 and negative 5. I'm going to get b minus 5, b minus 5, and b comes from just, that's the letter used in that problem. By writing this out like this, I've completely eliminated this. I've replaced it with something that's equivalent. So b minus 5, and this is times. I know the time symbol isn't usually written. b minus 5 times another b minus 5 will, in fact, if you distribute it out, will equal that. So then we go to our next step. We'll go back to our flowchart, even if you feel like you know what to do next. It says, before eliminating, check denominator for excluded values. It's saying, don't get elimination happy yet. Actually check for your excluded values early, because it's easier to do it now. So let's switch to our excluded values and see what we get. We have a b minus 5 and another b minus 5. Since they're the same, we don't need to do this process twice, but we need to take each of those, b minus 5, and equal them to 0. Just like we did before, we take the chunk of the denominator and we equal it to 0. And in this case, we want b alone, so we add 5 to both sides, and we get b equals 5. So the b equals 5 is our excluded value. If b is equal to 5, this problem does not work. If you're just looking at this saying, hey, I just need to figure out in my head what I could plug in here to make that group go to 0, well, what minus 5 equals 0? 5 minus 5 equals 0. And so you might be able to even do this step in your head and just say, oh, I know I plug in a 5. So the excluded value part we have done. It's when b is equal to 5, this problem breaks. And then finally on our flowchart, the last step, it says eliminate factors common from top to bottom. When we look at this problem, we have a b minus 5 up here, and we have another b minus 5 down there. Now, whether I choose the one on the left on the right or the right is irrelevant, but one of these eliminates with one of these, leaving me with nothing left on top that hasn't been crossed out, and on the bottom, a b minus 5. So if I'm writing my final answer, I have a b minus 5 down here. And when we have nothing left on top, we have to remember what operation we've been doing. We've been dividing something by itself. This chunk being divided by itself, whenever you divide something by itself, it always equals 1. So really, it's not 0 up there, it's not blank space up there, it's 1 over b minus 5 is our simplified fraction for this problem, with the excluded value being that when b equals 5, this does not work. Let's go ahead and do one more example, a little less talking through it and a little bit more just kind of working more quickly. Do one with only binomials, so no trinomial factoring. We'll start with the flowchart again. It says parentheses around the whole numerator and denominator, and then our operation is just going to be simplifying, so we'll drop to the bottom. So let's put parentheses around the whole thing, top and bottom. Next step down here says factor all groups fully. So let's go ahead and factor this thing up. And if we look at the bottom, m plus 4 is fully reduced, but our top, when there's two terms like that, they both have things in common. We can take that common factor out front. They both have a 3 in them that you can divide by. They both have an m that you can divide by. And when we take that out, 3m squared divided by 3m. 3 divided by 3 is just a 1. M squared divided by m is just an m. And then we have our plus sign. And then 12 divided by 3 is a 4. M divided by m is 1, so that goes away. And we're left with this on top. This has been replaced by this. Then it says, look at our denominator. Before eliminating, check the denominator for our excluded values. So m minus 4, or m plus 4 is the equation on bottom, or the expression on bottom. M plus 4, and we set that equal to 0 to find our excluded values. We subtract 4 from both sides, and m equals negative 4. Again, you may have been able to get that without writing all this out, but this is good practice for the more complicated ones. So there's our excluded value, and now let's get our main fraction fully simplified. It says, eliminate factors common from top to bottom. And we look at this, we're looking for things completely identical, top and bottom, in this big pile of multiplication here. And we have 3 times m times 1m plus 4 on top, on bottom just m plus 4. you'll notice that this and this look very similar but not exactly the same. And the reason is that 1 is not necessary to be written. M and 1m really are the same thing. And so if you wanted to write that without the 1, that's going to help it look identical. So now we can cross out these two identical things. We can eliminate those top to bottom, leaving us with just 3m on top, and again, as we had in the last problem, a 1 on the bottom. So 3m over 1 is simplified. And since we usually don't write fractions when they're just over 1, we just say it's a whole number, we would just write this as 3m. So all of this complicated mess here reduces to simply be 3m, with the exception of when m is equal to -4, this problem will not work. The answer will not be -12, it'll be some undefined thing. It's actually called a whole when we get things like that. So that is, you've got a couple more examples you can work through for section 2, and there's a couple more down on the next page as well. Good luck with those.